My name is Dr. Rajan, Professor at Department of Information Technology, K.S.Rangasamy College of Technology. Our topic is today's topic is for deadlock. It's our operating system subject. First we have to know what is my operating system, interaction between the users and hardware. That is the name is for operating system. If we can go for synchronization process, this is a process synchronization, concurrently the process running on your system. That is a problem name is for deadlock. We can see one by one. Here, to prevent the set of concurrent process from completing the task, okay, without delay we have to complete the task. How we can, what are different methods to providing or avoiding or detecting a deadlock in a computer system. First we have to know what is meant deadlock. You can see the example system having the two disk drive. Okay, P1 process and P2 process. We are using for two different type of process, P1 process, P2 process. Both the process holding for one disk drive and the other each need for the another one. Okay, so here we have the two different type of operation. One is for holding edge, another is for requesting edge. That is a waiting edge. Okay, that is a situation name is for deadlock. Without adjustment we cannot complete the operation. That situation name is for deadlock. First we have to know what is how we can graphically representing the system. So here resource that I have to mentioning for symbol is for R1, R2, etc. RM. Okay, each resource type having one or more instance. For example, I need for printer device. Okay, printer device is a resources, but I need for 4 printer devices. So here we have to count it as a 4 instance. What are the operation is possible? One is for requesting the printer, requesting the resource. That is the name is for request operation. Next, after getting the resource, we have to utilizing the resources. That is a use operation. Next, after the completion of the operation, we have to releasing the resource. So that is for the release operation. This is the common for system model, system design model. What are the characteristics for deadlock? First one is for mutual exclusive. That is only one process at a time they have to using the resource. So that means another process waiting on the queue. That is for the mutual exclusive. There is an understanding between the two processes. Next one is for hold and wait. We see in the previous diagram, P1 process holding the resource at the same time, P2 process requesting the same resources. So we cannot complete the operation. Next one is for no preemption. Without completing the operation, we cannot pull the resources, pull the process. That is name is for no preemption. Preemption means we have to pull the process in the operation. Next, circular wait condition. One process holding the resource, another process waiting the resource. Another process holding the resource, another. That is for the circular wait condition. Okay? That is a situation when we saw circular wait condition. We can see the diagram. Okay. The resource allocation graph. Using the resource allocation graph, how we can solving the deadlock. You can see the diagram. We are having 3 different type of process, P1, P2 and P3. Okay? R1 resource are having only single instance. R3 resource also having single instance, but R2 resource they are having 2 instance type. Okay, and R4 resource they are having the 4 instance. So here you can see the diagram. P1 process requesting the R1 resource. At the same time, P1 process holding the R2 resource. That means they have to utilizing the R2 resource. If they want to complete the operation means compulsory they need for R1 resource. But R1 resource, who is holding R2 resource? R1 resource, they are holding the P2 process. How we can complete the P2 process? P2 process holding the R1 resource and R2 resource, but requesting for R3 resource. Okay, then who is having the R3 resource? Only for P3 process having the R3 resource. Here you can see the circular wait condition, because here there is no circular. If P3 process is completed, automatically R3 resources can release. If the getting the R3 resource for P2 process also completed, then P2 process complete means automatically they have to releasing the R1 resource. So automatically P1 process also completed. So again there is no deadlock. Suppose we are having the P3 process requesting the R2 resource, there may be deadlock because they are having the circular. You can see the diagram P1 R1, then P2 R3, then P3, then R2. If they are having the forming a circle, that is a circular wait condition. They have a circle, compulsory the system going for the deadlock. Then here we have to know what is the requesting edge, what is the assignment edge. See the diagram. P1 process requesting the R1 resource. That is the requesting edge. Okay. Then holding edge. What is the holding edge means? P1 process holding the R2 resource. That is a symbol. That is a arrow. We can use it. Okay. So that is for the resource allocation graph. How we can mentioning the deadlock in resource allocation, through the resource allocation graph. Process they have to mentioning for the circle, the resource they have to mentioning for the rectangle or square, instance may be mentioning on the inside of the resources. Okay, that is the process requesting edge. P1 process requesting the Rj resource. Then what is the holding edge? Pi process by holding the Rj resource. Okay, that is the requesting edge, the holding edge. We already seen. You can see the diagram. Yeah. Now we can see first diagram there is no deadlock, but second diagram they are having the deadlock because they are having the circle. That's also we already seen on previous one. P1 process and R1, P2, R3, P3, then R2, then P1. They are having the circular. So compulsory the system going for deadlock. You cannot complete the operation. Okay. See the diagram. It's another exception. They are having the circular, but there is no deadlock. We can see here P1 process and P3 process. R1 resource they are having the two instances. They are having two instances. R2 resource are also having two instances. P1 process requesting the R1 resource, they are holding for R2 resource. Then P3 process holding the R1 resource and requesting for R2 resource. Then now P2 process holding for R1 resource. If P2 process is completed, automatically they have to releasing the R1 resource. At the same time, P4 process requesting for holding the R2 resource. Okay. If P4 operation is completed, automatically they have to releasing the resource. So now one resource R1 is free, R2 is free. Automatically P1, P3 also operation is completed. There is no deadlock. But they are having a circular wait condition, but there is no deadlock. There is an exception case. Thanks for watching.